Okay, so in the last video we looked at a C program with an array and loops. And remember, anytime you see an array, chances are there's a loop somewhere around the corner, because loops and arrays go together. And so you want to be sure you know how arrays work in C. You want to be sure you know how for loops and while loops work. Make sure that you can understand where you can run into problems, because you can run into a lot more problems in C compared to Java. Java, for example, so what we did in the last video was we took this program and put it into Java, made a few changes, so we got something like this. So for example, we don't have pound defined, so we used a final int, size equals 10. And in Java, memory for arrays is allocated on what's called a heap, which we will use later on in C, but for now we're not using it. And so in Java you can only use the heap to allocate memory for the array, whereas in C you can use both the heap and a different part of memory called a stack, which is used typically for calling functions, for allocating local variables. So all of these variables like int I, these things are allocated on the stack. And it turns out in the case of C programs, the actual array itself can go, in the case of C, it can go on the heap or the stack, but the array variable like AR is actually just a pointer, and that pointer can be allocated anywhere, but turns out if you just have this AR pointer is allocated on the stack, just like variables I and sum. Okay, so once again, just to repeat that, variables I and sum and AR, which is just a pointer, are allocated on the stack, but the actual array itself, so AR itself is just a pointer and does not contain the entire array. The entire array is allocated somewhere else. If you use what we used in this program, it turns out we are allocating this entire array on the stack. Okay, so just want to emphasize that. And we'll talk about this more in detail. In Java, however, all arrays, that is, in Java, if you were to take a close look, this AR would be on the stack, but the actual array itself will be on the heap, and we know it. It's pretty explicit, so well, it's sort of clear. Whenever you use new, you're using the heap. So that's a good way to tell. If you use new, you're using the heap. Okay, so we haven't had to worry about that so far, but now that we're getting to language like C, which is closer to the hardware, closer to the operating system, we will have to worry about things like this. So you have to keep track of where things are. Okay, having said that, we know that there's quite a few things wrong with this, so you want to take a close look at this. We started, for example, with index 1, while arrays always start with index 0. So we know that's a problem. We know that this is probably also a problem. Maybe we check for I less than or equal to size when we should be probably just going between indices 0 and 9. This will allow us to erroneously access array location 10 when there isn't one. And the result of that is in Java we get an array index out of bounds exception at value 10 for I. We do not see anything like that in C. So in C, the program runs. So if we were to run it, 64, program runs. It doesn't tell us that we're going out of bounds. This is the same program. It is going out of bounds, just doesn't tell us. Okay, so that's the kind of things you want to watch out for. Those are differences between C and Java. C is a lot more unsafe, allows you to do these things, doesn't warn you, and when you run it, it doesn't tell you that something is wrong. Whereas in Java, you get a clear indication that there was something wrong. You went out of bounds. Okay, so the kinds of things you want to take a look at are the indices, the condition in this loop, and also this condition. You want to make sure that this is doing the right thing. Okay, so take a look at these things and figure out what you can do to fix this. Make sure that it's working on any machine. It turns out that you might be able to run this on a Linux machine and get the right answer. But as you saw in the previous video, run this on a Mac OS X and you get completely different results. Okay, so now let's take a look at more detail in arrays. C arrays work pretty much the same as in C++ and Java. The main difference is that C allows a lot of unsafe operations with arrays, as we just saw in the previous programs. So, and this is used, it has been used historically for many years by viruses and malware to exploit security holes. So, and the reason was that a lot of those programs that were used in Windows were written in C, and you could exploit these unsafe use of arrays. We won't really get into that. So let's take a quick look at some of the basics of a C array. As we saw, we can declare an array like this. You can say this says that A is an array of 10 ints. That's how you would read it. I know it's a little bit different from the way we used it in Java. In Java, we would say int, open close square brackets, A equals new int, open close square brackets, and put 10 in there. So that means we're setting up an array A and allocating that memory from the heap. That's what the new means. In C, it turns out that you can allocate memory for an array right in the stack. And so that's a different way of doing things. Java doesn't allow you to allocate memory on the stack. Okay, so once you set up an array, chances are there's a loop somewhere nearby because arrays and loops go together so well. And if you want to index through all the elements of the array, set them all equal to 0. This is the kind of thing you want to do. Int I equals 0. Or actually, you cannot use int here, remember, unless you use the C99 standard to compile. By default, it's not used. Right, so for I equals 0, I less than 10, I plus plus, or plus plus I. Is there a difference between using plus plus I and I plus plus? Actually, it turns out this is just a tiny bit more efficient. And it's almost to the point where you don't have to even think about it. You could just as well say plus plus. I mean, I plus plus. It would be completely equivalent. No difference. Okay, so either one, I plus plus or plus plus I. Only tiny difference is this is a tiny bit more efficient. And we'll talk about why that's more efficient later. Okay, so then this statement, this is the loop body, sets the elements of A sub I, elements of A to 0. Okay, so how do array declarations work? The way we set it up in C is you say the type here, and the name of the array, and then in square brackets you specify the size. And as we saw, we can use pound defines. The rule is that the size has to be an integer at compile time. So you can use expressions. And so you can say size times 10, where size is defined somewhere else, for example. That would be perfectly fine as long as whatever you put in here is a valid integer. Okay, so here are some examples. You say pound define size 100 or pound define start times. Oh, this is just to set up the type of the array. So in this case, we're saying that we're going to use a double array of size 100 called time. Okay, You can initialize arrays just like you did in Java using open-close curly braces. So for example, you can say int, so you're saying AR1 is an array of type int, and there's 10 things, and so you can assign it of values for all 10 ints at one go, or you can assign just part of the array values in this and then assign the other locations elsewhere, or not even assign those values. You don't have to. You can also omit the size and just use the open-close curly braces to tell this tell C that this is going to be an array of size 8. That's fine too. You don't actually have to say exactly what the size is. It's optional if you use this notation, the open-close curly braces notation, to initialize. So if you had omitted this 10 over here, AR2 would be of size 3. Since you put the 10 here, you know that the system knows, C knows that this array AR2 is of size 10. Only the first 3 locations are initialized. The rest are not initialized. Okay. Arrays subscripts are pretty much just like in Java. A subscripted array refers to a single variable and can be treated the same way as other variables. So, for example, what that means is just that you can assign values to A1 sub 5. And I use the word sub to mean whatever is in square brackets. This is just a fast way of saying A1 index location 5. So I'll use the notation A1 sub 5. Okay, so the general idea is you use whatever array identifier you use, same rules as any other C identifier for names. And then in square brackets, you can use just a single variable like I, or a literal constant like 6 or 5, or you can use an expression. For example, you can use 10 times I plus j. That's completely valid. As long as I and j are defined and those values are known, this is perfectly fine. Or you can even use the return value of a function. So you call a function, pass that function the j value. It will return, hopefully, an int and not a double. If your function returns a double, this thing won't work. So as long as function returns an int, or something that can be promoted to an int, therefore, as long as those conditions are hold, you can use function calls and use the return value as the index. Or you can use even more complicated expressions involving function calls. Okay, so a subscripted array refers to a single variable and can be treated just as any other variables. We can assign values to it. You can use it on the right-hand side and so on. So if you have an array of 5 doubles, you cannot use, for example, a is equal to 3.14. You cannot do that. You have to say a sub something, a sub 0 or a sub 1, a sub 2, but you cannot do this. Okay, so a, then we would say a is not a valid L value. Okay, so next up we will take a look at many unsafe things that you can do with C arrays.